Finding a limit when you've got a radical in your expression, you'll need to use a conjugate. No, this is not Espanol, but that's what we call it in mathematics. So the conjugate comes from the part of the expression or the quotient that has the radical in it. And a conjugate is a binomial that is exactly the same two terms, only you change the sign in between the two terms. Don't change anything under the radical. Don't change this number, just change the sign between them. And I'm going to multiply this quotient, this fraction, by the same thing top and bottom. The reason we can do that is because if I multiply it by the exact same thing on the top and the bottom in fraction form, well, that's just like multiplying this times 1, because anything over itself is 1. Okay, I get it. So the conjugate I'm going to use is the square root of x minus 4 plus 2. Numerator and denominator. When I multiply this, it's like a binomial times a binomial, and you would distribute things out. In distributing, I end up with the square root of x minus 4 times the square root of x minus 4. I would like to think that you all know that when you multiply two square roots that are identical, it just cancels out the square root, and you're left with x minus 4. If I multiply this radical of x minus 4 times 2, then I end up with a positive 2 square root of x minus 4. Now I'm going to need to distribute the negative 2 to that binomial. Negative 2 times the square root of x minus 4 is negative 2 square root of x minus 4. And negative 2 times positive 2 is negative 4. By the way, when I multiplied these two square roots together and I got rid of the radical, it is a really good practice to put that in parentheses. Just as a reminder that if that had been subtracted, I would need to distribute the sign that's in front of it. So it's just a good habit to get into. In the denominator, I do not multiply anything. I just write down what I've got. So I've got an x minus 8. That goes together. And then I've got this other piece here that goes together of square root of x minus 4 plus 2. So let's simplify the numerator. First off, I notice I've got exactly opposites, which is the purpose of using conjugates to begin with, that are going to cancel out. So positive 2 square root of x minus 4, a negative 2 square root of x minus 4 cancels. Now I'm going to simplify what I've got in the numerator. I've got an x minus 4 and a minus 4. In the denominator, I've got an x minus 8 times a square root of x minus 4 plus 2. So what does my numerator simplify to? X minus 8. Perfect. Means I do know what I'm doing. After doing the factoring of 9.3, you should recognize when you have a common binomial in the numerator and the denominator of a fraction, they can cancel each other out. It doesn't disappear, it cancels out. It's the same thing top and bottom, so it is equivalent to 1. Well, I've just done a real big no-no. I have not brought the limit as x approaches 8. That doesn't mean anything at this point. So I'm still looking at the limit as x approaches 8, not infinity, 8. And now I've got 1 over just this binomial, square root of x minus 4 plus 2. Now I'm actually going to plug in this number that it's approaching in for x. 1 over the square root of 8 minus 4 plus 2. Well, the square root of 8 minus 4 is the same as the square root of 4 plus 2. What's the square root of 4? 2. 2 plus 2, 4. Therefore, my answer to this original problem is 1/4.